Hello from Slovenia, where I'm currently working doing research at the Karst Research Institute in Postojna for a year. Because of that, I wasn't expecting to be able to participate in the NSS convention this summer. So I guess one of the few advantages of having the convention virtually is that some of us who are further away or weren't going to be able to come in person can now actually participate. Today I'm going to talk about a project that we've been working on for the past few years in Greenland, and this is in collaboration with Jason Gully from the University of South Florida and a large team of grad students and researchers at South Florida and at the University of Arkansas. Particularly, I want to call out Jessica Mejia, who's a PhD student from South Florida working on this project, and Celia Truntz, who's a PhD student at Arkansas working on this project. And they've really done a lot of the background work that's kept the science going. Now, in the past, science and exploration have often really gone hand in hand. Big scientific expeditions that were also exploratory. And nowadays, that's becoming more and more rare. But this project is an example where we really got to do both at the same time. You know, we're conducting science, but we're also really doing true physical exploration. And so in the beginning of this talk, I'm going to talk a bit about the science and some of the background, and then how that motivates the exploration that we did later on. And then I'll talk about a couple of expeditions that we did to explore moulins on the Greenland Ice Sheet. The first one of those was actually sponsored by Red Bull, and the second one was sponsored by NSF, and we conducted last fall with Jason Gully and David Okel. And then I'll bring that back to the science and sort of what we've learned from the exploration that helps motivate probably some new directions in the science. So we're interested in Greenland largely because it contains so much water. And so I want to talk just first a bit about how big the Greenland Ice Sheet is. So it's 700,000 cubic miles worth of ice. And that's nearly 10% of the world's fresh water. So there's a lot of water held up in the Greenland Ice Sheet. If we think about the size of the Greenland Ice Sheet, it's roughly about the size of the US east of the Mississippi River. It's pretty big. In a lot of cases, the ice is more than a mile thick. And importantly, as Greenland melts, if we melt all of the ice in Greenland, this is enough water to raise sea level globally by 8 meters. So there's a lot of water there, and that water is increasingly making its way to the ocean. We wonder how quickly that's going to happen. And when we look into the future at sea level rise and looking at how quickly this is going to happen, Greenland is really one of the biggest players and one of the biggest unknowns. We haven't watched an ice sheet melt before, and we don't know exactly how quickly things are going to play out. One other fun fact to help you get your mind around how big the Greenland Ice Sheet is. This is a map that explains the gravitational influence of the ice in Greenland. So as you melt the Greenland Ice Sheet, it doesn't create a uniform rise in sea level around the world. Actually, the Greenland Ice Sheet, as it's there, creates a bulge of sea level around Greenland because of the gravitational pull of the ice. So this is a map of what happens if you get a meter of sea level rise on average from ice loss in Greenland. How much does sea level rise at different places around the globe? And actually around Greenland, sea level falls as ice from Greenland is lost. So that's just another way of thinking about how big Greenland is, how much water there is there. The gravitational pull of that water influences ocean levels globally. When we look at water loss from Greenland, there are two main processes that are driving it. One, you just have melt on the surface of the ice, and you have these streams that form and water is flowing off of the ice sheet. But then we also have motion of the ice towards the ocean and calving off of icebergs. And right now, about half of the mass loss each year is from each of these two processes. So about half of it's melt and about half of it is ice coming off into the ocean. And when we look at what's happened over about the last 20 or 30 years, roughly half a millimeter per year of sea level rise is occurring due to melt from Greenland. And as I just said, about half of that is from surface melt, and the other half is from the motion of the ice. So what happens to this surface melt? Most of the streams that form on the surface of the Greenland ice sheet, they end in moulins, and those are holes in the ice that carry the water to the bed, essentially through caves in the ice, and then through caves horizontally out to the edge of the ice sheet. And so most of this water is not just flowing off the edge of the ice, it's flowing underneath the ice through caves and out to the edges. Here's some pictures of those moulin features where you have large streams that go into deep pits, essentially, in the ice. This is essentially where most of the meltwater goes. And about 20 years ago, it was noticed that there seemed to be some correlation with the amount of meltwater and how fast the ice was moving. So it seemed like in years where there was more melt, the ice actually moved faster. And this was shown in a paper by Swally back in 2002, and it's been known since as the Swally effect. And basically the idea here is that this meltwater makes its way down through the moulins to the base of the ice, and then it lifts up the ice and also reduces the friction at the bed, lubricates things, and makes the ice move faster. And this is the sort of process that we're trying to understand better. We have models for this process, but they're not very well constrained by data. And so the main goal of our project was to go relatively far from the margin of the ice and to instrument moulins where we're lowering sensors down these pits into the water so that we can look at how the water levels are changing. And this is one of the few ways that we can test the models for how the water flows beneath the ice. As is often the case with international work, a lot of the adventure is just getting there. And to get to Greenland on an NSF project, the NSF has an agreement with the Air National Guard that does flights regularly back and forth between New York and Greenland. And so we actually fly to New York and we get a C-130 and get to ride it in style there in the cargo hull. And we first fly into Kangerlussuaq, which is where the Air Force Base is in Greenland. And then we get on a commercial flight and go up to Ilulissat, a bit to the north. Ilulissat is a UNESCO World Heritage Site. It's one of the main sources of icebergs in Greenland as well. And first we were fighting the mosquitoes and setting up and sorting through all of our gear. Many of you probably know Vicky here, who came with us on both of the summer field expeditions and then also one of the fall expeditions. And with her huge experience of living and working on ice, she was a big help in figuring out all the logistics and dealing with the day-to-day difficulties of living on an ice sheet. So we were really happy to have her involved in the project. And as you can see, we have a huge amount of gear here we had to sort through, and all of this had to get packed into helicopters and sent up onto the ice. So finally the time had come and we started loading things into helicopters, including grad students. And when we first got up onto the ice sheet, we got our tents set up and then it started snowing. And this is the first season up there. It snowed off and on for about a week and a half. And we were really kind of stuck there in camp. We hadn't walked around much before the snow fell. We didn't know where there might be crevasses or moulins that could be covered up by the snow. So our very first field season, we spent nearly 2 weeks sitting in the cold in camp and sort of twiddling our thumbs and waiting for the snow to start melting. Luckily it did, and we started to be able to do what we had come to do. In the meantime, about the only thing we could do was set up the weather station, which you can see it's saying that it's cold. So finally we started to be able to walk around. Snow melted. Here you can see a stream that we, anywhere you go, you find yourself crossing a lot of these streams. A lot of the difficulty of getting around is finding places that you can get across the streams. This is Celia, a PhD student working on the project. And the Greenland Ice Sheet is incredibly flat on the large scale, but on the small scale, it's pretty rough. And so you're constantly going up and down these little slopes or trying to find a way to get around some canyon like this. And so it's actually not a very easy place to get around, even though it's so flat. One of the things that was novel to me, because I hadn't worked on an ice sheet before, are these Kovacs flights. So you can actually drill holes quite easily into the ice, and you can stack these on top of each other. So you drill in a flight, and then you switch it out, and you put another one on top, and you can drill 20, 30 feet into the ice surface like this. You just have to be careful that you don't let the drill bit sit in one place for too long, because it'll freeze in place, and you can lose the whole bit. One of the other weird things about living on the ice sheet is that your tent actually protects the ice from melting. So you can see here there's this lifted area of ice. This is where my tent used to be. And after about a week of melt, the tent just starts kind of sagging in more and more, and eventually you can't stand it anymore, and you move your tent to a new place. So every week or so we had to move all the tents around because the ice sheet is melting around us. We also had a sort of a mini lab set up in one of the tents there. The main thing we were using this for was actually mixing fluorescent dyes, which we weren't using as is often used in karst for tracing. We were using it to actually measure the discharge in the streams on the ice sheet by pumping dye in at a known rate and then measuring the concentration. One day I walked out of the tent and found this suspicious looking character wandering around on the ice. And during our first expedition, for a few days, we had a New York Times photographer come out and join our camp to take some pictures. And we weren't normally putting this much dye in the water, but we decided to give him something to take pictures of. And so we did a couple of injections of larger amounts of dye, mostly for the pictures. But it turned out to actually be pretty interesting to see where exactly the water was going. This is the first moulin that we attempted to instrument, and instrumenting these moulins was actually pretty tricky. So we're lowering a pressure transducer hundreds of meters down into this hole and try to get it as far into the water as possible. Water level is typically about 100 meters down, and the river is pouring into these holes, and so these cables that we're using to lower them down have to be very strong. So they're armored cables. And each of them was typically around 500, 600 meters long. So they weighed a few hundred pounds. And we had to somehow get these across the ice sheet and from our camp and to a place where we wanted to instrument the moulin. And how did we do this? There was sort of an important routine that we developed. So you wake up in the morning, you have your first cup of coffee, and then you have some breakfast. Then you have your second cup of coffee, and then what you really need is some motivational music. So it was hard work getting those cables in, and we actually had a lot of trouble with instrumenting, especially our first Moulin that we attempted. We spent about 2 weeks lowering cable in and pulling it back out and trying different things until we eventually were successful. So we got pretty good at the running the Hall system to pull the cable back out of the hole yet one more time. One of the other fun things about working in Greenland is the weather is always changing, and often it's interesting. And this was just an example where we had a nice sundog going on. Also, when you work there in the summer, it's continuously light. So this was about as dark as it would get. And you would just get hours and hours of this kind of magical low-angle light in the evening. Of course, there's pretty much continuous wind. That was one of the things that rarely changed. It was more how strong was the wind. You just get a katabatic wind coming off of the ice pretty constantly at about 20 miles an hour, and on a bad day, 30, 40 miles an hour. One other thing that we did was some drone flights, and we were using this to map the area and try to figure out exactly where the water was coming from that was going to the moulins. Here we are about to launch the drone, which was always kind of exciting, sometimes resulted in a crash. Landing was even more tricky because it's a pretty rough surface to land on, and there are little slush puddles everywhere. Nice, successful launch. And from the drone, we were taking photos of the whole area, and we're able to use photogrammetry to construct a DEM and then do water flow routing across that surface. We also get a really high resolution orthophoto that we can use to look at the area. And just to examine or to demonstrate how high resolution this is. So this is our camp, our kitchen tent. We keep zooming in. You can actually see my trekking poles, which are right here. So something like less than an inch pixel resolution over this whole area that we mapped. And here there's just an animation of that 3D model with the orthophoto draped over it, which helps to give you an idea of what the terrain looks like. You can see all this low-level roughness that you have to deal with when you're walking around. So after the first season, one of the most surprising things we found in the data were related to how much the water level was changing over daily timescales. And we had 2 sites at 2 different camps, and in both cases, the water levels were changing much less than had previously been observed in moulins. And particularly in this site even further up on the ice, there really was low variability in these daily water levels in the moulin. And when we look at the model for flow in the system and change parameters in the model that we don't know, really the only way we could produce these low ranges of variability was to add a lot of storage in the moulin itself. And it seemed like it was too much storage for it to be the moulin. So we needed some kind of big void space, and we weren't really quite sure what that might be. And this led to the first expedition up into the moulins on the ice. Jason, a couple of years ago, was contacted by Will Gadd, who's one of the world's top ice climbers, who was interested in going and seeing some glacier caves and had gotten Jason's contact information. And Jason convinced him that what they needed to do was go into a moulin on the Greenland Ice Sheet. And Will Gadd was able to convince Red Bull that they should fund this. And so this was the way we got funding for the first expedition up there, where they went and explored a moulin that was relatively close to one of our field sites. And you can go check this out. It's up. There's a short documentary, a little over 15 minutes long. When you see the link up here, it's pretty entertaining. You can see the first adventure that they had exploring this moulin. The big surprise, though, was how much void space there really was inside this moulin. It was much bigger volume than we had really imagined was possible. So the moulin dropped into this big chamber. And with this discovery, actually, and tying into our water level variations, we were able to convince NSF to fund a second expedition up there this last fall, where Jason and David Okel and I went up and explored a moulin that was more on a site where more variability in water level had been observed, to see if there was a contrast in the size of the moulin. And so again, we flew up through Ilulissat, checked out some icebergs. It's a little colder this time of year. There's more sea ice starting to form. Also, you get great northern lights this time of year. We had those pretty much every night. The helicopter flight is always nice because you get great views of the glacier on the flight up. This is the part of the ice sheet that This is where the part of the ice sheet we work on comes out to the ocean. Our camp is kind of way off over there somewhere. So we get dropped off in the helicopter. It's always an interesting feeling to get dropped off on the ice sheet and have the helicopter fly away and realize you don't have any way to get back until the helicopter comes to get you. It's a pretty strong sense of isolation out there. And you can also get trapped for days if the weather's bad, because the helicopters can't fly in bad weather. The big surprise when we got up there, though, which you might be able to tell, is that A, there was no snow, and B, it was above freezing. So there was actually a little bit of melt. We're coming in the fall where we were expecting temperatures to be -10, -20, -30. We weren't expecting above freezing temperatures in October, but that's what it was. So we sort of lay down on the pile of gear while the helicopter flies away. First order of business is to set up the tents so that we have some place to shelter ourselves if the weather starts getting nasty. Again, we use these Kovacs flights to drill holes into the ice and then put in bamboo poles as stakes for the tents, which works pretty well. Then we went over to check out the moulin, and to our horror, we could hear the sound of water flowing into the moulin. It wasn't really strong, but there was a clear sound of a waterfall. And we come this time of year because we want everything to be frozen and dry, and we weren't sure if we might get completely skunked because we just wouldn't be able to enter the moulin because there was too much water. So we started setting up an anchor, and here again we use these Kovacs drills. Here I'm hand drilling one, and we drill a V-thread and thread some webbing through that in order to make an anchor. Here you can see we make 2 of those anchors and then equalize to the static line running off to the moulin. Jason went to take a look, hung over this edge of the moulin for a second and decided it looked quite unstable with loose fractured blocks of ice and that we should come from a different angle. And so we went and placed anchors in the old stream channel that the water used to flow through to the moulin, or over the top of the moulin. And again, we have 2 of these V-thread anchors. And at this point, Jason again got in, took a look, and then kind of came back up to the edge and was like, "Okay, Matt, you want a rig?" And I couldn't tell if he was just freaked out or if he just really wanted to take photos. And my guess is it was a little bit of both. So I was kind of like, "Yeah, okay, I guess I'll rig." And So I go to the edge and set up a nice Y-hang there with some ice screws, and then rappel on down and set up another rebelay below the lip and start working my way down. Below me, I can just see blackness as far as I can see. Here I am just below that rebelay. I think I went down, rigged one more rebelay, and went a little bit further, and sort of decided that the things I was seeing in the ice in terms of fractures and so on, I wanted Jason to have a look at them before I decided, before I went any further down. And so I climbed on out, chickened out, and it was Jason's turn. He went down, took a look, went a bit further, came back up, and he's like, yeah, it's fine. Okay, we'll continue on. So we got down to a ledge, which was maybe about 50 meters from the top. I think I got a photo of that. I'll photo that in a minute. This is looking up roughly from where that ledge is towards the entrance. Most mornings, again, motivation is the tricky thing. You're in the nice warm tent and there's a stiff cold wind outside. And the hardest thing to motivate for is to take your turn at the bucket, which is sitting out in the wind, and you get to sit on it and do your business, which is never very pleasant, especially if you're getting pelted by blowing snow. Okay, so we went back into the moulin. Again, this is a picture from somewhere near that ledge, looking up towards the entrance. We were able to rig a series of rebelays kind of back into this alcove to reduce the risk of somebody above knocking stuff down on somebody below. And then this is the view looking down from that ledge towards the bottom. And down here, it was pretty creepy because there were these continuous popping and crashing sounds. So it would, it was like pop, and you could hear stuff falling into the water down below. It's just, I don't know, it's nerve-wracking when you're in this big shaft completely made of ice and you just continually hear popping and crashing sounds. Luckily, they were mostly coming from below us. To get a little better idea of the scale there, this picture is taken from about where that caver is and looking down towards another ledge. And this is actually as far as we were able to make it. So the waterfall was on this far wall, and we were able to avoid it by keeping the rebelays on the opposite wall until here. And then in order to continue down from there, we would have had to have gone right into the water. And we could also see the bottom, which looked like this. And we sort of knew that was that. We could even shoot a survey station down there without any trouble. This is the view looking up from that last ledge below the bottom. And here there was a kind of nasty looking fracture going into this block. And I think it was the last day we were working in there. It seemed like it was getting bigger. And we decided not to go below that anymore at that point. It just looked too much like this whole piece might come off. So after we bottomed the cave, we spent a few days surveying and taking lots of photos, taking video. We wanted to document it as well as we could. Here we are doing the survey using a Disto X. And we were using TopoDroid on an Android tablet. Made the survey pretty fast. Here's a rare picture of Jason. Most of the pictures are made by Jason of someone else, but Jason actually goes in these places too. Here we are reviewing some of the video footage that Jason got. And David Okel here, another day in the office here with his crampons and his laptop. Like I said, we had pretty spectacular northern lights. Most nights, if you were willing to stay up late, you could see some good northern lights. And we got some good wind. We got a snowfall, and it covered everything with snow for a little while, and then the wind picked up and just scoured everything clean. I always kind of wonder, where does that snow go? And we figured out one place it goes, which is into the Moulin. So the last day that we were working in the Moulin, it was clear and sunny on the surface, but with a strong blowing wind. And the wind was blowing drifting snow into the entrance. And so it was snowing in the Moulin all day long. It was hard to look up into it. It would just blind you. Jason wanted to take lots of pictures of this, which was a lot of fun. And there's Jason after the experience. You can see he's totally coated with snow. His camera was also a little worse for wear. I think he dried it out and it was okay. After this last day, we spent the day just packing up our gear and getting ready for the helicopter to come. But then the next morning when we woke up, it was totally socked in. And we called on the sat phone to the pilot, and he said, yeah, we definitely can't fly right now. And it was like that all day. And so they canceled, and we're going to try again the next day. And we woke up the next morning, still completely socked in, and we were starting to wonder how long we were going to be there. Luckily, we had a pretty big reserve of Mountain House, so we weren't going to start starving anytime soon. But we had pretty much run through most of our books and everything, and we're starting to run out of things to entertain ourselves. Luckily, towards the end of that second day, there was a window just enough where it was clear both in Ilulissat and on the ice sheet, and they were able to fly up, grab us, and pull us out. These are maps of the two moulins that were explored. This is the moulin that was first explored by Will and Jason in 2018 that had this huge volume. And what we found in the Fox Moulin, which was the one that we explored last fall, was that it was much more like we had imagined, relatively uniform shaft going down without this big volume. And when this had been instrumented before, it had very high variability in water level. And so it sort of makes sense with what we have observed from these water level variations. But it also brings up a question, which is, why these differences? We don't really understand what leads to large or small volume moulins, and we probably need to observe a lot more variety of these things. We need more exploration in order to start to understand the physical factors that are creating these differences, which are important in terms of how the ice basically processes the water that you give it and how much it will make the ice slide. And with that, I'll thank you for your time, and hope to see you in person at the next convention.